to apply our result, we observe that as a ball runs down a ramp, a pendulum released here, where equilibrium is at the ramp, pendulum released at this point will go over and back and over and back to the ramp by the time the ball reaches the end of the ramp. So the pendulum will be right over the ramp at the end if the pendulum has a length of 34 centimeters. Now I'll say we didn't do that with a great deal of care, but I hope when everybody did the experiment, they did take as much care as they could to figure out just what the motion of the pendulum was as the ball rolled down the ramp. Well, if we use this formula, which incidentally applies in the ideal case, and there are things are going on here that aren't quite ideal, so I'm thinking you might have a few percent error in using this method to get the time, even if you can precisely determine the motion of the pendulum as the ball rolls down the ramp. However, as a good approximation, we're going to use omega equals square root of g over L for the angular frequency of the motion of the pendulum, with L equal to 34 centimeters. The calculation is very straightforward, and here it is, and I estimated 5.3 reciprocal seconds, and it turns out it's more like 5.4 or maybe even 5.5. I don't remember how it rounds off, but it's a little bit more than this. It's at least 5.4. It was 5.4 something. I don't remember what the difference was because I wasn't really at all concerned with that. I know you can calculate that. Okay, and we note that omega is in the units of angle divided by time. Okay, because of course the reciprocal second means we're dividing by units of time, and 5.3 with nothing after it means 5.3 radians, doesn't it? Okay, so that this is in radians per second. So I say here, and I say the same thing here, just omega equals 5.3 reciprocal seconds, which means 5.3 radians per second, radians times reciprocal seconds, or radians over seconds, okay? So then the question is, how long does it take to go down the ramp? Well, people said 1 3/4 cycles. How long does it take to complete a cycle? We've got omega, how long does it take to complete a cycle? Well, 2 pi is about 6.28 radians at 5.4 radians per second, correcting for the 5.3. We find that it takes, I said about 1.2 seconds for a cycle, okay? And then in the example we used, it took about 1 3/4 cycles, and 1 3/4 multiplied by 1.2 gives us pretty close to 2 seconds. It takes about 2 seconds, but hopefully you had a very refined estimate of just how long it did take, because you can really determine this with a fair amount of accuracy, even using this function, which isn't quite accurate for the real-world pendulum. Okay, well, that's how we use the pendulum, at least today, to measure the time interval.